Dear Edward, this is the example that you asked me to explain. So we have the function f of x equals sine of x, and we have the associated polynomial sine of x does like this. Like this, and the maximum value that can take is plus 1. All the values of sine of x is between plus 1 and minus 1. So, first of all, the function is f of x. Second fact, the polynomial, the Maclaurin polynomial, third degree Maclaurin polynomial of the function sine of x is p3 of x is x minus x cubed divided by 3 factorial. This function will do something like this, very similar. It will do something like this, and it will do something like this. It will be matched at x equals 0. But when you go and you evaluate the function at the point 0.1, you are next to the 0, but the value of the function, this is the polynomial, and this is the function, the value are slightly different. Let's go to put 0.1 here. 0.1 here, 0.1 here, so the value of the function is sine of 0.1. Sorry that I put it so far from the 0. It should be, but I want you to see that the polynomial will say different value. So there is an error. What is this error? The error is here. What is this error? The theorem say that the remainder, the error, because the function f of x is the polynomial p3 of x plus the error. The error is r4 or r3 of x. And r3 of x, this error, the theorem say that exists a point z between 0.1 and 0. 0 is the center, is the point where you are doing the Maclaurin polynomial. Between z and 0.1, it exists a point whose this relation will take place. R3 will be the fourth derivative of z evaluated z divided by 4 factorial multiplied by x to the 4. So this is the error. This is the error. So I want to see when if I choose the point 0.1 and by plugging on the polynomial, I will obtain a value 0.1 minus 0.1 cubed divided by 3 factorial. I will obtain a value. I want to know what is the maximum error that I can make, and the maximum error is here. But we don't know where is the point z. But we know that the fourth derivative of the function is the first derivative is cosine, the second derivative sine or minus sine, and the third derivative is the function is sine of x. The first derivative cosine of x. The second derivative minus sine of x. The third derivative, the derivative of sine is cosine minus cosine of x. And the fourth derivative is sine of x. But we know that the function, the maximum value that the fourth derivative can take is between 1 and minus 1. So f of x at any point, at the point z that I don't know, this point z, at this point z, the maximum value should be less than 1. So I will use these facts to make an approximation of the error of the maximum error. So the problem continues doing the f of 4 is sine of c divided by 4 factorial, but sine of c is less than 1, this 1. So it's 1 divided by 4 factorial by x 0.1 raised to the 4 power. So the error is very small, even taking two terms of the Maclaurin polynomial, only taking these two terms, the error is so small compared to the real value. You see, the value of the polynomial is 0.099, and the error is 0.00004. Wow, a small error here on this. The error is on the digit 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The error is here on the 3. Wow. Good approximation. So I hope this will make you to understand how this theorem of the error of the remainder that is left, of the remainder that you need to add to the Maclaurin polynomial to produce the correct result. So this is the error, this one is the error, this one is the polynomial, and the error in this case for a third degree polynomial is very small. That's all.